Now that we've looked at some graphs of hyperbolic trig functions and some identities associated with them, we're going to try to go ahead and establish some derivative rules. Now I'm going to go ahead here and start by trying to calculate the derivative of the hyperbolic sine function. So you'll see here I'm using this derivative notation that says I want to take the derivative of this function, and I'm going to slowly start to simplify this down. Now taking derivatives here is pretty easy to do if I'm able to kind of just go back again to the definition of the hyperbolic sine. So remember here I'm going to have e to the x minus e to the negative x, remember sine subtract, all over 2. So if I wanted to take this derivative, one of the first things I might notice is that I do have a quotient here, right? So I might think about using the quotient rule, but since my denominator is just a number, I'm going to go ahead and actually pull out that value of 1/2 to make my life a lot easier. I'd like to avoid using the quotient rule whenever possible, and this seems like an easy way to do it. Because now I'll recognize that I just used constant multiple rule, pulled out the constant, I can take the derivative of the stuff that's left. That of course is pretty simple because if I take the derivative of e to the x, I get e to the x. And when I take the derivative of e to the negative x, I'm going to get e to the negative x, chain rule, take the derivative of negative x, and that's going to get me a extra negative. And so I've turned it into this. So here's the derivative. Now, interestingly, you might notice, what is this the same as? Well, if I was imagining taking this set of brackets and putting it back on top of that fraction, you might see this looks exactly the same as the hyperbolic cosine. So the derivative of hyperbolic sine is hyperbolic cosine. That's just like our regular trig derivatives, right? Derivative of sine was cosine. That's super easy. Now I'm going to ask you to go ahead and see if you can try to calculate out the next derivative, that is the derivative here for the hyperbolic cosine. So I'd ask you to pause the video here and see if you can try to work through this on your own. And then when you hit unpause, you'll see me working through the solution. Okay, so I'm assuming that you tried this on your own, but here's what I ended up with. Again, if I kind of swap this over into the definition of the hyperbolic cosine, I can again pull out a 1/2. Avoiding the quotient rule makes this really, really easy. And then taking my derivative becomes very simple. Derivative e to the x is e to the x. Derivative e to the negative x is e to the negative x. Chain rule, I'm going to multiply by an extra -1. That's going to make the negative pop out here. And very interestingly, this is the same as the hyperbolic sine. Notice here, this is a bit different than what we know about derivative of regular cosine, because derivative of regular cosine was negative sine of x, and here there is no negative. Now, at first this might seem disappointing because it seems like now we're going to have an extra thing to memorize, but it's actually pretty nice that this comes out as just hyperbolic sine with no negative on it. One of the worst things about the derivative rules that we had with regular trig was when we wanted to start doing antiderivatives. So notice how easy this becomes. If I say, where does the hyperbolic cosine come from? You can easily just answer, it comes from the hyperbolic sine. Where does hyperbolic sine come from? It comes from hyperbolic cosine. But when I start to take a look at things with our regular trig functions, if I say, where does negative cosine come from? What do you take the derivative of, right? What's the antiderivative of negative cosine? A lot of times those negatives there start to cause some problems. It makes it a little bit confusing. Those were some of the head-scratching moments in Calc 1 that you might recall. But with this, it's so easy and straightforward. One just always turns into the other. Now, in a very similar way, we could establish derivative rules for all of these hyperbolic trig functions. I'll go ahead and write down the results that we get here. We know that we've already seen up above, derivative of hyperbolic sine is hyperbolic cosine, vice versa on the next. There is a similar relationship to much of these other ones. Notice that what's the derivative of regular tangent? It should be secant squared? Well, then here we'll see that we actually end up with hyperbolic secant squared. Do you remember what the derivative of regular cotangent was? It was negative. Remember, derivative of all the cos used to be negative with trig functions, the original ones. So like cosine, cotangent, cosecant, they all had negative results. But yeah, that was a negative cosecant squared. So here we get a negative cosecant or hyperbolic cosecant squared. I'll go ahead and jump down to this one, hyperbolic cosecant. Do you remember what the derivative was for regular cosecant? Again, we know it should be negative. And yeah, it was a cosecant cotangent. And so here I have the same thing, just hyperbolic. Secant was originally, or its derivative was originally secant tangent, and here I'm going to get pretty much the same thing. Hyperbolic secant, hyperbolic tangent, with one strange occurrence. It's going to be negative. It's almost kind of like the negative that used to occur here has now migrated down to here. That negative swapped positions. It's no longer occurring on the cosine, but it does occur on the secant. So fortunately, these derivative rules should be fairly easy to recall if you know your regular trig derivatives. And of course, if we understand how to do derivatives, we certainly understand how to do antiderivatives, and that will make the process of doing integration much, much easier with these functions. In the next video, we'll take a look at some of the applications that we've seen throughout Chapter 2 and see how we can attempt to perform those sorts of operations and calculations with these new hyperbolic trig functions.